Welcome. Today, we are looking at chemical bonding, focusing on ionic and covalent bonds. This is a key topic in your chemistry exams for SS1. Pay close attention. Let us begin. First, let me explain what a chemical bond is. A chemical bond is the force that holds atoms together in a compound. Atoms form chemical bonds to achieve a stable electron configuration. This usually means having 8 electrons in the valence shell. This is called the octet rule. Atoms can achieve the octet in 3 ways. They can lose electrons, they can gain electrons, or they can share electrons. The type of bond formed depends on the elements involved. There are 3 main types of chemical bonds: ionic bonds, covalent bonds, and metallic bonds. Ionic bonds involve the transfer of electrons from one atom to another. Covalent bonds involve the sharing of electrons between atoms. Metallic bonds involve the sharing of electrons among a sea of metal atoms. In this lesson, we will focus on ionic and covalent bonds. Now, let me explain ionic bonding. Ionic bonding is the electrostatic attraction between oppositely charged ions. It occurs between metals and nonmetals. Metals tend to lose electrons to become positively charged cations. Nonmetals tend to gain electrons to become negatively charged anions. The oppositely charged ions attract each other. This attraction is the ionic bond. For example, sodium chloride is formed by ionic bonding. Sodium is a metal. It has 1 valence electron. It loses this electron to become a sodium ion with a positive charge. Chlorine is a nonmetal. It has 7 valence electrons. It gains 1 electron to become a chloride ion with a negative charge. The sodium ion and chloride ion attract each other. They form an ionic bond. The resulting compound is sodium chloride, which is table salt. Ionic compounds have several characteristic properties. They are usually solid at room temperature. They have high melting and boiling points. They are soluble in water, but insoluble in organic solvents. They conduct electricity when dissolved in water or when melted. They form crystal lattices. The ions are arranged in a regular repeating pattern. This gives ionic compounds their hardness and brittleness. Now let me explain the formation of ionic bonds in more detail. When a metal atom loses electrons, it becomes a cation. The cation has a positive charge. The charge on the cation is equal to the number of electrons lost. For example, sodium loses 1 electron to become Na+. Magnesium loses 2 electrons to become Mg2+. Aluminium loses 3 electrons to become Al3+. When a non-metal atom gains electrons, it becomes an anion. The anion has a negative charge. The charge on the anion is equal to the number of electrons gained. For example, chlorine gains 1 electron to become Cl. Oxygen gains 2 electrons to become O2. Nitrogen gains 3 electrons to become N3. The charges on the ions must balance in the compound. For example, sodium chloride has 1 Na+ and 1 Cl. The charges balance. Magnesium chloride has 1 Mg2+ and 2 Cl. The charges balance. Aluminium oxide has 2 All, 3+, and 3O2. The charges balance. The formula of an ionic compound is determined by the charges of the ions. The crisscross method is used to find the formula. For example, Al3+ and O2 combine to form Al2O3. The charges cross over. The 3 becomes the subscript for oxygen. The 2 becomes the subscript for aluminium. Now, let me explain covalent bonding. Covalent bonding is the sharing of electrons between atoms. It occurs between nonmetals. Nonmetals have high electronegativities. They do not lose electrons easily. Instead, they share electrons to achieve a stable electron configuration. In a covalent bond, each atom contributes 1 or more electrons to be shared. The shared electrons are called the bonding pair. The atoms are held together by the attraction between the shared electrons and the nuclei. For example, hydrogen gas is formed by covalent bonding. Each hydrogen atom has one valence electron. Two hydrogen atoms share their electrons. Each atom now has two electrons in its valence shell. This is the stable configuration of helium. The shared pair of electrons is the covalent bond. Chlorine gas is formed by covalent bonding. Each chlorine atom has 7 valence electrons. Two chlorine atoms share one pair of electrons. Each atom now has 8 electrons in its valence shell. This is the stable octet. Water is formed by covalent bonding. Oxygen has 6 valence electrons. It needs 2 more to complete its octet. Each hydrogen atom has 1 valence electron. It needs 1 more to complete its duet. 2 hydrogen atoms share electrons with 1 oxygen atom. Oxygen shares 1 electron with each hydrogen. Each hydrogen shares its electron with oxygen. The resulting molecule is H2O. Covalent compounds have several characteristic properties. They can be solid, liquid, or gas at room temperature. They have low melting and boiling points. They are often insoluble in water. They do not conduct electricity. This is because they do not have ions. Now, let me explain the types of covalent bonds. There are single bonds, double bonds, and triple bonds. A single bond involves the sharing of one pair of electrons. For example, hydrogen gas has a single bond. Chlorine gas has a single bond. Water has single bonds. A double bond involves the sharing of 2 pairs of electrons. For example, oxygen gas has a double bond. Each oxygen atom shares 2 electrons with the other. Carbon dioxide has double bonds. Each carbon-oxygen bond is a double bond. A triple bond involves the sharing of 3 pairs of electrons. For example, nitrogen gas has a triple bond. Each nitrogen atom shares 3 electrons with the other. The number of bonds formed depends on the number of electrons needed to complete the octet. A single bond is formed when 1 pair is shared. A double bond is formed when 2 pairs are shared. A triple bond is formed when 3 pairs are shared. Multiple bonds are stronger and shorter than single bonds. Now let me explain coordinate covalent bonding. Coordinate covalent bonding is a special type of covalent bonding. In a coordinate covalent bond, both electrons in the shared pair come from the same atom. The atom that provides both electrons is called the donor. The atom that receives the electrons is called the acceptor. Coordinate covalent bonds are common in complex ions. For example, the ammonium ion is formed by a coordinate covalent bond. Ammonia has a lone pair of electrons on the nitrogen atom. A hydrogen ion has no electrons. The nitrogen donates its lone pair to the hydrogen ion. A coordinate covalent bond is formed. The resulting ion is NH4+. The bond between nitrogen and one of the hydrogens is a coordinate covalent bond. Coordinate covalent bonds are similar to regular covalent bonds. They have the same strength and properties. They are often indicated by an arrow pointing from the donor to the acceptor. Now let me explain the properties of ionic and covalent compounds. Ionic compounds have high melting and boiling points. This is because the ionic bonds are strong. A lot of energy is needed to break them. Ionic compounds are soluble in water. The water molecules surround the ions and pull them apart. Ionic compounds conduct electricity when dissolved in water or when melted. The ions are free to move and carry charge. Ionic compounds are hard and brittle. The crystal lattice is strong but rigid. When struck, the layers shift. Like charges repel. The crystal shatters. Covalent compounds have low melting and boiling points. This is because the intermolecular forces are weak. Little energy is needed to overcome them. Covalent compounds are often insoluble in water. They are soluble in organic solvents. Covalent compounds do not conduct electricity. They do not have ions to carry charge. Covalent compounds can be gases, liquids, or solids at room temperature. The state depends on the strength of the intermolecular forces. Now, let me explain the difference between polar and nonpolar covalent bonds. A polar covalent bond is a bond in which the electrons are shared unequally. one atom attracts the electrons more strongly than the other. This creates a partial positive charge on one atom and a partial negative charge on the other. The bond is polar. For example, the bond in hydrogen chloride is polar. Chlorine is more electronegative than hydrogen. The electrons are pulled towards chlorine. Chlorine has a partial negative charge. Hydrogen has a partial positive charge. A nonpolar covalent bond is a bond in which the electrons are shared equally. Both atoms have the same electronegativity. There is no charge separation. For example, the bond in hydrogen gas is nonpolar. Both atoms are the same. The electrons are shared equally. The bond in chlorine gas is also nonpolar. The polarity of a bond depends on the difference in electronegativity between the atoms. If the difference is small, the bond is nonpolar. If the difference is large, the bond is polar. If the difference is very large, the bond is ionic. Now let me explain the concept of intermolecular forces. Intermolecular forces are the forces between molecules. They are weaker than chemical bonds. They determine the physical properties of substances. The three main types of intermolecular forces are van der Waals forces, dipole-dipole forces, and hydrogen bonds. Van der Waals forces are the weakest. They occur between all molecules. They are caused by temporary dipoles. Dipole-dipole forces occur between polar molecules. The positive end of one molecule attracts the negative end of another. Hydrogen bonds are the strongest intermolecular forces. They occur between hydrogen and highly electronegative atoms like oxygen, nitrogen, and fluorine. Hydrogen bonds are responsible for the unusual properties of water. Water has a high boiling point because of hydrogen bonds. Ice floats because the hydrogen bonds form an open structure. Hydrogen bonds are important in biological molecules like DNA and proteins. A common exam question asks you to distinguish between ionic and covalent bonds. Here is a sample answer. Ionic bonds involve the transfer of electrons from a metal to a nonmetal. Covalent bonds involve the sharing of electrons between nonmetals. Ionic compounds have high melting and boiling points. They conduct electricity when dissolved or melted. Covalent compounds have low melting and boiling points. They do not conduct electricity. Ionic compounds form crystal lattices. Covalent compounds form molecules. Another exam question asks you to explain the octet rule. Here is your answer. The octet rule states that atoms tend to gain, lose, or share electrons to achieve a stable electron configuration with 8 electrons in their valence shell. This is the configuration of noble gases. Atoms achieve the octet by forming chemical bonds. Metals lose electrons to achieve the octet. Nonmetals gain or share electrons to achieve the octet. Another exam question asks you to give examples of ionic and covalent compounds. Here is your answer. Sodium chloride and magnesium oxide are examples of ionic compounds. Water, carbon dioxide, and methane are examples of covalent compounds. Ionic compounds are formed between metals and nonmetals. Covalent compounds are formed between nonmetals. Each type has characteristic properties. Let me give you a quick summary. Chemical bonds hold atoms together in compounds. Ionic bonds involve the transfer of electrons. Covalent bonds involve the sharing of electrons. Ionic compounds have high melting points and conduct electricity. Covalent compounds have low melting points and do not conduct electricity. Coordinate covalent bonds involve shared electrons from one atom. Polar covalent bonds have unequal sharing of electrons. Intermolecular forces are weaker than chemical bonds. Practice these concepts. When you have them down, move to Topic 7.